Hi all, welcome to the machine learning course. Today we are going to discuss about the basic concept of machine learning and what are the different types of machine learning algorithm, all these things. First we have to understand the difference between the machine learning and rule-based system differences. Rule-based system means it produces predefined outcomes that are based on the set of certain rules coded by the humans. For example, a bank customer's personal and financial information can be measured against a programmed set of levels, and if the numbers were to match, then your home loan would be granted. This is an example for the rule based. Here, everything are the hand designed futures. And the next one is the machine learning. Here, the algorithm analyzes the data set and determines the relationship within the data. And here the logic is embedded in the algorithm and was not coded by the human. The model trained itself and learned from the data, and it creating a cohesive relationship between data inferences and future data outputs. That is the major difference between the rule-based system and machine learning. Now we are going to see the differences between the ML versus rule-based algorithm. The rule-based algorithm, human involved in all aspects, but in the machine learning, no humans are involved. And the system characteristics of rule-based one is deterministic, and the machine learning one is probabilistic. And the learning algorithm for rule-based is none, and for the machine learning, the statistical rules are automatically learned by the machines. And for the project scale, the rule-based algorithms are not scalable, and for the machine learning, it is easily scalable. And for the data set, for the rule-based, it contains only the simple and smaller data, and for the machine learning, large and good quality of data is used for the accurate predictions. That is the difference between the rule-based and machine learning algorithm. And now we are going to see when to use the machine learning and when to use the rule-based algorithm. First we will see about the rule-based algorithm. Here the situations in which there are lower volume of data, that time we can use the rule-based algorithms because the rules are relatively simple and it requires the speedy output. If you're having the smaller volume of data, we can get the output quickly, so we can go for the rule-based algorithm. And also when there is a clear and constant data distributions, if it is means we can go for the rule-based algorithm. And next one is when to use the machine learning. When simple rules or guidelines don't apply means we can go for this ML. And also to handle the complex rules and intensive issues with a relatively variable environment. And for the long term, as it is more manageable to constant improvement and enhancement through the algorithm and data preparations. And also the data distinction changes over the time and requiring the constant adaptations of the program, that time we can go for the machine learning algorithm. The next topic is the rational understanding of the machine learning algorithm. Now you are aware of the data sets. So we are having the data set that we can use it for training purpose and testing for purpose. For using the cross validation method, we can have 70% or 80% data for training and the remaining either 20% or 30% data for testing purpose. So we are finding the best model, and then we are trying to execute the training the model using the 70% data set, and we are getting some output that and from the output we have to check it whether there is error in that. If the error is there means again we have to apply the cross validations method, and again we have to train the model with some of the different types of methods. Also we can go for the ensemble method to improve the accuracy. Okay, here the target function is unknown, and because the learning algorithm cannot obtain the perfect functions. Here we are going for the hypothesis functions that approximates the target functions, but maybe the different from the function f, different from function f. Next we are going to see the different types of data that is available In broad term, it is categorized into categorical data and numerical data. These are the two types. The categorical data means the variable that has the value that can be only placed in the categories such as yes and no. For example, the marital status, either they can say yes or no. The political party, either maybe they may belong to the particular political party or no. And they can define the eye colors also, only the few colors, right? So, and then census, high and low, all these things are belonging to the categorical data. And second type is the numerical data, the variable that have values that represent the quantity. Quantity means the real values. Here there are two types, one is discrete and another one is continuous. The discrete means the fixed values. For example, number of children and the defects per hour, these are the counted items, so that is comes under the discrete value. And the second type of the numerical value is continuous value. It never be fixed one, it keep on changing. For example, weight. So if we are measuring our weight on today's 1 o'clock, means it measures some value. After half an hour or 1 hour, after 1 day or 1 week or 1 month, if we measure it, means either our weight increased or decreased. In such a case, this is a continuous value. It is not the fixed one, it keep on changing. Similarly, voltage, the sales value may be little higher on one day and little lower on another day. And another best example is account balance. It is not the fixed one. It may be some, you may have some credit value, that time it may be higher, and if you are withdrawing some amount, means it may be the lower value based on that. And the sensor stream data, all these are continuously changing values, so it is a continuous value. If it is fixed, means that comes under the discrete. If it is keep on changing, means that is a continuous value. Now we are going to see the different types of machine learning algorithm. It is classified into two major types. One is supervised and another one is unsupervised learning algorithm. Supervised means the name indicates that it is a presence of supervisor as a teacher. It is when we teach or train the machine using the data that is well labeled, which means some data is already tagged with the correct answers. After that, the machine is provided with the new set of examples, so that the supervised learning algorithm analyzing the data, the set of training examples, and produce a correct outcome from the labeled data. That is why it is called the supervised learning. It is a type of the machine learning algorithm where algorithm learn from the labeled data, meaning that the data comes with correct answers or classification. For example, labeled data set of images of elephant, camel and cow would have each each image tagged with the respective names. If it is so, it is easy to predict it. So that is the supervised learning algorithm. And the next one is the unsupervised learning. Here, it is a type of machine learning that works with the data that has no labels or categories. Here, the goal is to find the patterns and the relationship in the data without any guidance. Okay, here in this approach, the machine analyzed unorganized informations and it groups based on the similarities or patterns or some differences. Unlike the supervised learning, here there is no teacher or training involved. The machine must uncover hidden structures in the data on its own. That is the main thing. Okay, for example, the unsupervised learning can analyze animal data and group their animals by their traits and the behaviors. These groups could correspond to the different species, making it possible to organize the animals without pre-existing labels. That is the major advantage of using the supervised learning. Okay, there are two types in the supervised learning. One is classification and another one is regression. And for the unsupervised learning, clustering and association. In the upcoming slides, we will see all the different types of the supervised and unsupervised learning algorithm in detail. Now we are going to see the supervised learning algorithm. It is the supervised learning is when input variable x is called features and the output variable y called the labels or classes. Use an algorithm to learn the mapping function from the input to the output. That is y is equal to f of x. The goal here is to approximate the maximum mapping function so well that when you have the new data that you can predict the output variables for the data. This is example for the supervised learning. Here the supervisor is there, that is they play the role of the teacher. Here we are having the label data. Here you can see two images. One is Tom and another one is Jerry. Here they have labeled the name. If it is in one color means that is Tom. If it is in the brown color means that is Jerry. So they have labeled it. Okay, so you know that if the image comes like this color means you know that it is a Tom or Jerry. Okay, now we are applying this data to the machine learning algorithm and we are trying to find for the new testing data whether it is a Jerry or Tom. If it is so, based on the previous training examples we can find that whether it is a Tom or Jerry. Now we are going to see about the supervised learning classification. The classification predictive modeling is the task of approximating a mapping function f from the input variable x to discrete output variables. The output variables are often called the labels or categories. The mapping functions predicts the classes or category for a given observations. The examples for the classification problem is the person is boy or girl. So answer is either yes or no. Is the email spam or not? And if she is happy or not. So you will get the output as either yes or no. So that's why it's a classification problem. The second supervised learning type is the regression. It comes under the real values. So the regression predictive modeling is the task of approximating a mapping function f from the input variable x to the continuous output variables. Continuous output variable means it is a real values such as integers or floating point values. Okay, for example, it is a we can mention that as a quantities like amount, price, size, etc. The examples of what is the price of the house. So today it may be a 1 lakh, tomorrow it may be 1.5 lakhs, the day after tomorrow it may be a 2 lakhs, after years or 2 years or 5 years ago it may be a crore. So it keeps on continuously varying. So it is a continuous output value. Output. Then another example is what is the height of the students. So it is not the fixed one, it keeps on increasing. So it is a regression value. Next, we are going to see about the unsupervised learning. Here, we are having only the input data and there is no corresponding output label. The goal for unsupervised learning is to model the underlying structures or distributions in the data in order to learn more about the data. Okay, so the algorithms are left to their own devices to discover and present the interesting structure in the data. So we don't have the any label data. Instead, the system itself will try to find the patterns either based on the clustering or any types of algorithms, k-means, K-NN algorithm, any such algorithms are there to find the patterns or clusters among the data sets. This is the example for the unsupervised learning. Yeah, here we are having the group of fruits as a training data. Here we are having apple, orange, banana, all these things. We are going to train this model and we are going to test with the apple. Okay, and we have to find it whether it is belonging to the which cluster, either it is a apple, the red color or blue color or green color. That is what we are going to find it. We are not going to classify this. Instead we are going to cluster this, what type it belonging to, either it is a apple or either it is a orange type or it is a banana. So we are going to clustering this one. This example for unsupervised learning algorithm. Next, we are going to see the differences between the regression, classification and clustering. The regression means uh, It is a both the regressions and classification comes under the supervised learning algorithm. Clustering and association comes under the unsupervised learning algorithm. For the classification, output is categorical value. For regression, output is continuous value. And for the clustering, we are assigning the data point to the clusters. And come to the next difference. The regression, the main aim is to forecast or predicting it. For example, predict the stock market price. And for the classification, here the main aim is to compute the category of the data, whether it is belonging to the particular thing or not. For the example, uh, we are checking whether the email is a spam email or not. And for the clustering, finding all the fraud transactions, that is the clustering. The example algorithms for all these types are: for the regression, the algorithm is the linear regression, and for the classification it is a logistic regression, and for clustering it is a k-means. The machine learning algorithms are classified into three types. One is supervised, unsupervised, and type is the reinforcement learning. Okay, it is quite different from the other two machine learning algorithm. In the supervised learning, some class label is there to define the output. In the unsupervised learning, the model itself will learn from the data. This reinforcement learning is differ from the other two types. Okay, here there is no training data is available. Entirely this algorithm works based on the reward based systems. Okay, so it involves an autonomous agents that observes the environment and then select an actions that will lead to the rewards. The reward may be a positive one or negative one. So this helps in the algorithm improving in the long run on its own. The best example for the reinforcement learning is most of the gaming applications are working based on this reinforcement learning only. So based on that, the agent may get the reward or punishment. So the system will learn either it is a reward or punishment, no problem. Thank you for your listening. Happy learning.